The content that we are going to start is implementing Cisco SD-WAN solution, I-MEDITA. Exam code is 300, 415, and the version of the exam is currently 1.2. So all the other exams are at 1.1. This SD-WAN exam is currently at 1.2. Earlier, like SD-WAN exam 1.0, it did not have like any security related tasks. Then they went to exam code 1.1, where they added SD-WAN security, and then exam 1.2, they added some new features in the SD-WAN. So currently we are at the exam number or version 1.2. So if you just search ENSDWI 300, 415, and you click on the first link, the very first link that we have here, implementing Cisco SD-WAN solution. If you clear this exam, passing this exam earns you the specialist certification, Cisco certified specialist. Remember that you will not become a professional, you will not be a CCNP, you will become Cisco certified specialist if you clear the specialist in the SD-WAN certification. If you clear this particular exam, this is one of the concentration exam that is required for CCNP as well. So if you want to be a CCNP, you have to take a core exam and you have to take a concentration exam. So SD-WAN is one of the concentration exam, and then you can take the core exam and you will become like the CCNP. But until you have taken the core exam, until you have cleared this NCore, enterprise core exam, or simply just the core exam, you will not become the CCNP. You will just become a specialist, the specialist in the SD-WAN technology, for example. So if you want to be a professional, if you want to be a CCNP certified, then alongside with the SD-WAN exam, you will also have to take the NCore exam or enterprise core exam, which will test you on a lot of other things. But our focus is not on the core exam at the moment. The focus is on the SD-WAN exam. You can also use this exam for the certification. Okay, fine. It's a 90-minute exam. It's multiple choice, like MCQs are going to be there. Some sort of like match, like, there will be like two tables and you have to match one part from the other. That kind of questions will be there. So mostly multiple choice questions and these matching questions, these kind of questions are presented in this exam. At the very end of our content, at the very end of our classes, we will also be able to see what type of questions are expected in the exam as well. So we will talk about that, but at the very end. At the moment, just we have to focus on the content that we will have to cover. For example, what are the topics that we have to cover from the exam point of view? So just click on the view ENSDWI exam topics. Just click on this button and it will show you, for example, what topics you have to cover in order to clear the particular exam. So the topic that we have to cover, the entire content of the SD-WAN is divided into these 6 parts: architecture, controller components, controller deployment, router deployment, policies, security, quality of service, and at the very end we have management and operation. So from the architectural point of view, we have to cover a few things. From the controller and the router deployment point of view, we have to know about certain things, then the policies, then the security and quality of service, and then the management and operations. These are the topics that we will have to go through, and then it is expected that you will get the questions in the exam based on the following modules. Once you clear all those, like, then only you will be able to pass the exam. So percentage wise, it's 20% architecture, 15% controller deployment, 20% router deployment, and so on. So overall content is divided into a total 6 parts: architecture, controller deployment, router deployment, and then one of the most important topic of the whole SD-WAN is going to be this policy. Then security, what are the security features available in the SD-WAN natively? Implementing those features will not require like any kind of dedicated firewall, IPS, IDS devices. Or how can we implement the quality of service in the SD-WAN? The management and operation related things, then day 2 operations basically we will talk about as a part of our content. So these are like total 6 units parts that we have. Our content is divided into these 6 parts. If I expand these 6, you can always download this. You can download it and keep it with you so that you can track what topics are covered, what topics are left. Although we will cover everything from the content point of view, but again, it will be your responsibility to cross-check everything. If all the topics are covered or if anything is left, you will inform me, like if anything is left, we will cover it. Although we are going to cover everything that is there in the content. So if I expand it, so first section is going to focus on the SD-WAN architecture. What is SD-WAN? Why we need SD-WAN? what are the components of the SD-WAN, how to design the SD-WAN infrastructure, how to connect the SD-WAN infrastructure to the cloud, what are the routers available that are supported for the SD-WAN platforms and all, what are the technical, what is this control plane, what is this management plane, what is this data plane, orchestration plane, basically how the SD-WAN architecture is, and something called multi-region fabric, or in short like MRF. MRF architecture of the SD-WAN. MRF architecture is something new that they have introduced. It was not available with the earlier version of the SD-WAN exam and in the SD-WAN software as well. So MRF, or multi-region fabric MRF architecture, how it works and all, we'll talk about that as well. So the first unit basically is going to focus on the architecture. Second and third units are going to focus on the deployment of those architectural components. Such as in SD-WAN, we have two main components. One component that we have in the SD-WAN is basically the controllers. And the second components that we have are the SD-WAN edge devices, routers basically, that we can connect in our environment and manage from the centralized controller. So what are the SD-WAN edge platforms? How can we deploy them? And what are the SD-WAN controllers and how can we deploy them, manage them, operate on them? So controller deployment and the router deployment, what are different options for the controller deployment? How can we deploy the controllers on the cloud, on premises? Describe, not implement, by the way. So how the controllers are deployed in the cloud, how the controllers are deployed on the premises, installing the controllers on the hypervisor or the cloud platform, scalability, redundancy, configure the certificates. Basically, when the controllers are deployed, we have to install some certificates for the authentication authorization process. So we'll talk about the certificate installation, and any issues that we might encounter, we will troubleshoot it from the controller deployment. 15% content, more focused on the theoretical aspect of the SD-WAN controller deployment rather than the practical one. We will talk about the practical deployment on premises as well, but we will focus more on the certificate installation and how each and every device authenticates themselves on the controller. Then the router deployment. What are these SD-WAN routers, for example? What are these WAN edge devices? What is this VH device? What is this CH device? What are these like SD-WAN devices, SD-WAN edge devices? We will talk about it. What is this? How the SD-WAN devices are going to secure the communication between two branches? What the concepts are used in that, we will talk about that. What is this underlay? What is this overlay? What is this concept of tunnels? What is this TLOC? What is this OMP, TLOC? What are the protocol options that are available with the SD-WAN edge devices? How the multicast is supported? What is this new feature called configuration groups, feature profile and workflows? Basically, router deployment and operating on the router, how to deploy the SD-WAN edge device and how to operate on that SD-WAN edge device, such as, for example, installation of the SD-WAN edge devices and then making them reachable to the rest of the network and configuring protocols such as OSPF, EIGRP, BGP, VRRP, how to do the CLI configuration and all that thing, how to push the configurations using the templates and all those things are basically covered under the router deployment section. By the end of this router deployment, in our topology that we are going to work on, we will have like complete end-to-end reachability. We will have a complete end-to-end reachability by the end of these 3 units. By the end of these 3 units, we will have a complete end-to-end reachability in our lab environment, in our lab topology. And you will know about the protocols, templates, and all the things that you should know from the basic operations point. Policies, for example, policies are the ways, policies we can deploy, policies we can implement in order to control our traffic flow. If you want to control how the traffic must flow from one point to the point, for that we have this concept called policy. So basic policy is going to control how the data traffic, data policy basically means how your data traffic flows. Data policy basically means how the data will flow from one device to the other device. Such as we have 2 transport. One is like internet and one is like MPLS. And we want that for our certain, we want that when the traffic goes from like branch 1 to branch number 2, here is branch number 2. When the traffic goes from branch number 1 to branch number 2, the data must go via the internet for like certain applications, and the data must go via the MPLS for certain application. So we can, for example, here we can configure various policies to change the way our SD-WAN network is going to work, our SD-WAN network is going to operate. Things such as like hub and spoke policy, full mesh policy, dynamic tunnels, selecting what transport we have to use, deciding what routes we are going to learn and all. Control policies basically means the policies that we can implement on the control plane, and the data policy basically means the policies that we can implement on the data traffic. Configure end-to-end segmentation, VPN segmentation, topologies and all. Application aware routing, direct internet access. Basically, policies are most probably the most important topic of your SD-WAN. The rest like deployment and configuring the templates and all those things is pretty much easy. But when it comes to policies, a few complexities are there. So policies are the topics that we have to focus a lot on. We will cover approximately like, I believe, 20-25 policies, small policies. Rest you can, once you know how to implement the policies in the network, you can decide to implement more and more policies completely up to your requirement. But policies are one topic that we should focus a lot as compared to any other topic in our SD-WAN. In most of the production environment, you will notice that the SD-WAN network might already be running. So you just need to deploy some templates. You just need to deploy some policies in order to change the way your SD-WAN fabric powers the data, learns the routes and everything. So those policies and templates we will focus a lot on. Of course, we'll talk about the deployment and all the other options, PNP, ZTP, whatever. But we will focus a lot on the templates and the policies option. And it's all configure, by the way. It is all configure. So it's all practical. It's completely like practical. I will describe what this policy is going to do, and we are going to implement that policy right now. So it's more focused on the practical rather than the theoretical discussion. Then when SD-WAN came in the market, like Cisco was like one of the few vendors that used to provide the SD-WAN solution. They were more like the leaders in the SD-WAN. But later on, like other vendors also adopted this SD-WAN solution. Versa, VeloCloud, other Citrix, all these other vendors, for example, are also available in the market nowadays. So one of the key challenge for Cisco when it comes to the SD-WAN, proposing the SD-WAN solution to the customer, actually, one of the key challenge, one of the major problem that they were facing, actually, that customer was saying that, okay, you are offering me an SD-WAN solution. Fine. Okay, fine. You are offering me an SD-WAN solution. If I get your SD-WAN solution, I basically get the routing. I mostly get the routing, WAN routing, I mostly get the routing function. But for example, if I opt for the Palo Alto or Fortinet, for example, as the WAN solution, if I deploy this Palo Alto or Fortinet, for example, the SD-WAN solution, not only we are going to get the routing at the WAN level, whatever amount of functions are available, not only we are going to get the routing at the WAN level, but we are also going to get enhanced security, because Palo Alto firewall that is equipped with the SD-WAN functionality, Fortinet, firewall, for example, equipped with the SD-WAN functionality. Other vendors also there. So they say, why should we deploy you solution if I can go for Palo Alto, where I get the basic routing, which is sufficient for me from the WAN deployment point of view, and we are also going to get a lot of security features. So why should we deploy your routing only SD-WAN solution, where I get the routing along with the SD-WAN from the vendors such as Palo Alto or the Fortinet, for example. Other vendors, other security vendors also. Palo Alto, Fortinet, these solutions became way more popular than Cisco, actually. Then Cisco already had a few security features, but Cisco then announced that what you can do, you can implement some basic security features on your SD-WAN router itself. You can implement some basic security feature on the SD-WAN router itself. So here is your SD-WAN router. In this SD-WAN router, the routing functionalities are going to be there. And you can also implement some security functions with the help of some virtualization concept. You can also implement some security functions such as application aware firewall, IPS, URL filtering, AMP, SSL, TLS proxy, trust check, DNS security, SIG. You can implement service insertion and chaining. You can implement these security features right on the box itself with the help of the SD-WAN controller. You can configure the security policies, and you can deploy those security policies on the box. And the box is not only going to then perform the routing, but it is also going to perform the security for your. These features might not be as good as offered by a dedicated firewall, same of these features, like also offered by the normal firewall. I'm saying that these features might not be as good as having a dedicated firewall at your branch. But if you have a small branch where we want to enforce some basic security, or even if you have a medium scale branch and there you want to enforce some basic security based on like URL filtering, advanced malware protection, IPS, and all those things, we don't need to purchase like any additional hardware for the same. We can just download a security application image from Cisco website. You can upload that security application image on that SD-WAN router. You can install that security application image on that SD-WAN router, and that SD-WAN router, based on the policy, that SD-WAN router will not only perform the routing now, but will also be able to enforce these securities in the network. So what are these? Although it says describe, but we will implement as many security features as we can in our lab environment. We will be able to implement as many features as we can in our lab environment. For example, we will be able to implement service insertion, application aware firewall, IPS, URL filtering, AMP, SSL, TLS proxy also. DNS security requires umbrella subscription and all. I will explain the concept. A SIG, where we want to connect our SD-WAN solution with the cloud delivered firewall and all. So what is this SIG and all? I will explain you these features. I will show you how to implement them, but we will not be able to practically implement it. But anyway, so whatever features, like, as many features as we can implement practically, we will definitely do it in a practical way as well. But most of these features, as per our content, they are only discussed. Then how to implement, how to better the user experience, like, how to improve the user experience for different type of application traffic. So how to improve the user experience for the certain application traffic that comes under the quality of service. So since we are talking about the routers, and on the routers we can implement some QoS features. So what quality of service features, what quality of service features are in fact available that we can implement on our SD-WAN device? What are these application quality of experience? What are these features that we can implement to improve the application quality of experience? TCP optimization, DRELs, packet duplication, forward error correction, application and AV. What are these options we will talk about as a part of our content? Again, a few of them we will implement practically as well. Whatever is possible, we will implement practically, such as this, such as this, such as this. We will be able to implement. I guess we will also be able to implement this one as well. So whatever features are like, possible to implement practically, we will definitely implement them practically, even though it just says this type, but we will have the practical implementation of the same as well. And then at the very end, we are going to go for the management and operation. Here we are going to talk about our day two operations, such as like image. If we want to do the image upgrade, REST API, what is this API concept, software image management, AAA authentication, monitoring, reporting, how to configure like authentication, how to configure monitoring, reporting, how to configure these things from the vManage, all these things. Basically, some day two operations we will talk about as a part of our SD-WAN. This is the content that we will basically focus on. These are the topics that we will specifically focus on. Apart from that, a few things that are not mentioned here, we will talk about them, such as a few additional concepts, such as tunnel group, such as like these feature profiles, such as sub interfaces, a few more things here and there we will talk about. But we will make sure that all the things that are there in this official content are covered first. And then if some time is left, then we will talk about some additional topics that you must know from your content, from your production environment point of view. So this is the content that we will focus on, by the way. There is a dedicated certification exam. So if you cover this content, not only you will be ready for the NRC, not only you will be ready for this ENSDWI exam, but you will also be ready for the CCI lab exam. CCI lab exam also, for example, has the same topics. CCI lab exam, that we have. CCI lab exam also has the concept like SD-WAN. So if you go through like the CCI lab exam topics and you just click on it, in the CCI lab exam also there is a dedicated section called software defined networking. If you click on it, there are two things. One is SDA and one is this SD-WAN. So in SD-WAN, same exact thing, same exact thing, same exact thing, same exact thing, same. So they do not focus like a lot in the SD-WAN. They don't ask like a lot of things in the SD-WAN. So this content is way more like in detail as compared to this one. So if you go through this ENSDWI content, you will not only cover the SD-WAN from the ENSDWI, but also from the CCI lab exam, and not to mention, of course, not to mention the NCore exam. In the NCore exam, whatever topics of the SD-WAN are, you will also be ready for that. So our content will focus on three certifications. One is going to be like NCore, whatever SD-WAN topics are there, those will be covered. Then ENSDWI, the dedicated certification exam, and the CCIE lab exam. So this is like the third certification that our content will focus on. So after completion of the classes, they will neither require the dedicated classes for the NCore, nor we will require for the CCIE lab exam as the topics. You will not require like any further more classes dedicatedly for the NCore or the CCIE lab exam from the SD-WAN point of view. This is a topic that we are going to go. These are the topics that we are going to. So any doubts, any questions that we have in the content, what content we are going to cover, or any doubts, anything you want to ask, you can ask. Let me know doubts so far.
Hey, I have a quick question.
Yeah,
Can you hear me?
Yeah, I can.
So, what is the prerequisite for this course as
Yes,
well?
okay. So for the SD-WAN, since it's not an associate level of certifications, a few things you must already know before you begin your SD-WAN classes. One of the very basic thing that you must already know is like the basic routing. You must know, for example, like what is routing, why we use routing, what is an IP address, all the basic fundamentals regarding what is a router, for example, what is this iOS, all these like basic things you must know. And you must also know about the routing protocols, such as what is this OSPF, what is this static routing, what is this EIGRP, what is this border gateway protocol. It's not like you should know about all these things in very much detail, but at least like a basic to intermediate level of knowledge will be required. For example, I am not going to tell you what is border gateway protocol, why we use border gateway protocol, what is this concept of AS number, why we use AS number in BGP, EIGRP, those basic concepts, basic fundamentals of the routing. I should already know. What is EIGRP, where to use EIGRP, where to use BGP, basic fundamentals about the routing, very first thing that you should. It's not like you have to go through the MPLS and the internet and in very much detail about the DM VPN and all those things. No, just the basic understanding means like the beginner to intermediate level of understanding. If you have about the routing topics, then it will be like okay.
Perfect. Thank you.
Second thing that you must know, for example, security. When it comes to security, our content specifically says that we have to implement the security. We have to, although we will talk about like what is this intrusion prevention system, what is this URL filtering. But if you have the knowledge of security before you reach out to this part of SD-WAN security, then it will be an advantage, because then you will just be able to deploy all those features without any problem. Else, for the detailed, we will talk about this content in a little bit in theoretical. But for the detailed discussion, actually, you will have to cover these topics from a dedicated security content. In whatever module of security these topics are covered in detail, you can cover it from there. And then you can see how the SD-WAN basically implements these things using the templates, using the policies. So a little bit understanding of the security terminologies you should also have. Same goes for quality of service. Our content says implement quality of service. Although we will talk about what is this policing, shaping, and all those things, but we are not going to discuss the quality of service in detail. It is part of our CCIE curriculum. So we are, of course, not going to discuss like the topic of quality of service in detail, like what is this giving, shaping. Quality of service requires like 4 to 5 days, a dedicated, content like is there for the quality of service, which is typically covered in the CCIE routing curriculum. So here you should be familiar with the basic terminologies of the quality of service, like what is queuing, what is shaping. Rest we are going to talk about it, and rest we are going to practically implement in our content as well. So, but the basic understanding, if you already have, then it will be beneficial.
Perfect. Thanks. I do not have that, but I believe you are going to cover in CCI routing.
Correct. I
Those.
will do it, but I will explain the basic things about this polishing,
Mhm.
shaping, giving. What I can do just when we start over this topic before the classes, you can just before like one day before the class, you can just remind me. I will provide you with some videos of on YouTube or some portal, so that you can at least quickly like revise about the or know about the terminologies, and then whenever dedicated content of the routing starts, then we will focus in detail about these. Same thing can be done for the security, same things can be done for the other topics that you might not be that much familiar.
Okay, makes sense. Thank
Right.
you.
Also, like for example, when we are talking about the controller deployment on the cloud, and if you want to deploy the controller on the cloud actually, then of course you will have to have the knowledge of the cloud itself. Like what is this AWS, what is this Azure, what is this concept of VPC, what is this concept of VNet, what is this availability zone, what is this reason. If you want to actually deploy the controllers on the cloud, we expect, or I expect, that you will at least have the understanding of the cloud terminologies and how the cloud works, and then it will be easier for you to deploy those things, deploy the controllers on the cloud. So the point basically remains that the if you want to deploy the controllers on GCP, for example, Google Cloud Platform, then you will have to have the understanding of the GCP and its terminology to deploy the things on the cloud respectively. So point remains the same. Point is basically, if you want to deploy the controllers on the cloud, you must have the understanding of the cloud as pure SD-WAN content point of view. It's not required. It's not required like to know about cloud terminologies, AWS, Azure, because a little bit we will talk about, and rest like we will focus more on the on-premises deployment. But if you want to, again, if you are managing the SD-WAN services in your production environment, and if they say that we have to deploy the controllers on the cloud, then of course either you will have to find a cloud engineer, otherwise you will have to learn about the cloud deployment respectively.
Yeah, control deployment is a day one activity, right? So
Yes, the very
basically,
basics. Correct. Very basics.
so policy is a day two activity where the support
Correct.
teams.
Once everything is up and running and we want to influence our SD-WAN architecture as per our requirement, there we are going to deploy the policies. Correct. Similarly, I'm going to tell you right here that if you plan to deploy the controllers on your premises, if you are planning to deploy the controllers on the premises, controllers are basically just the softwares that we will have to install on some virtualized environments, such as, for example, ESXi, basically on server. Controller is just a software that we will have to download from Cisco website once we have purchased the solution, and we will have to install it. If you want to go for the on-premises deployment, then you will have to deploy that on the server. Server is basically a hardware device that can provide you various services. A hardware device that is equipped with a lot of resources, RAM, CPU, storage, and all. So basically on server, we have to deploy these controllers. And on the servers, we have server operating systems. We have these things called hypervisors, such as ESXi, we have KVM, Hyper-V, we have different hypervisors. So if you again want to deploy the controllers on the premises, then also you will have to have the understanding of the servers. Server virtualization, you will have to have a little bit understanding of the server virtualization. You have to know what exactly is a server. What is this concept called virtual machine? What is this concept called, what is that vSwitch? What is this concept called port group? How to basically map the virtual interfaces, the virtual network interfaces with the vSwitch, and how to connect the vSwitch with the physical switch and all. So you will have to have the understanding of the server side or server virtualization, just in case if you want to deploy the controllers on the premises. Else, you will need to find someone who knows about the server virtualization, who knows about like ESXi or the KVM or the Hyper-V, and then you can ask them to create a virtual machine where you can deploy the controllers in a virtualized environment on your premises. Again, does not concern us, not the part of our curriculum. But again, if you are the network administrator and if you are someone who is responsible to deploy the controllers on the premises for the customer or for your organization, then you will also need to learn a little bit about the server virtualization. So that topic you will also need to go. It's not very hard actually. Whatever things are relevant in our content from the server side of server virtualization point of view, it's very easy. So if you spend like 1 or 2 days exploring the options available in the server, you will be able to understand each and everything properly. But dedicated, for example, training or dedicated, for example, you will have to study dedicatedly. You will have to study for that part, like server virtualization. Again, you will find plenty of YouTube videos on the server virtualization. You will find plenty of videos for security, quality of service, and all those things. So it is not going to be like very hard, but these things you must know if you are going to deploy and manage the infrastructure of the customer or even your organization by yourself. These are the prerequisites that we have before we begin our SD-WAN content. Most of them are just like when we have to do the deployment, when we have to enforce the security policies and everything ourselves. But if we have a dedicated security team, we can have a discussion with them like what kind of security feature will be beneficial, and then you can just follow some videos or documentation to deploy those security policies or quality of service without any problem. But still, at least like these are the things at least you should know before we begin our basic. Medium, I will say like beginner to intermediate level of knowledge is required for these kind of topics. The rest, like you don't require the very detailed knowledge of MPLS, DMVPN, GRE, IPsec. You don't require like a very detailed understanding of these things. All you need to know is that MPLS, internet, these are just the transport. All you need to know is that IPsec is just a protocol that is required for a secure communication between two endpoints over in secure network such as internet. From these topics point of view, you will not require like a lot of detailed discussion on the same. So beginner to intermediate level of knowledge is sufficient.
Is this only Viptela, like this?
Yes. We will focus. Yes, we will focus specifically on the Catalyst SD-WAN, which is based on like Viptela. So we will not talk about the other solution that the Cisco offers, which is Meraki based SD-WAN. We will have a little bit discussion about the Meraki based SD-WAN, but we are not going to go in detail of it. Meraki SD-WAN is mostly like completely cloud delivered, so we can't practice anyways. So I will brief you on this Meraki based SD-WAN solution, but our content is specifically going to focus on the Catalyst SD-WAN based on Viptela. Other vendors also we're not going to talk about, such as Versa.
Hardware involved, is it? Everything is VM only?
Everything is
VMs only, virtual machines, or
like,
do we have any hardware?
No. It's going to be like completely virtualized environment. That is why if you want to build your own lab at your home environment, it is possible to. So if you want to build your own lab, then let's say there are two ways that you can take to do the lab. Either you can get the lab access from here, like online lab access. So you can drop a message to your account handler whenever our lab content starts. You can drop a message to your account handler, and you can ask them that you want the lab access for this particular time period. So it is like 4 hours per day. 4 hours per day, whatever time slot you choose, it is going to be like 4 hours per day. On 4 hours per day basis, you can do the practice of your SD-WAN topics. So you can get the online lab from here. However, in the online lab, you will face a few challenges since it's all virtualized. A few challenges will be there. We will talk about those challenges. If you can manage the resources, you can build an offline lab as well, but that will require like a lot of resources. If you do not have that much amount of resources, then you will have to rely on the online lab and the challenges that you might face. But if you have sufficient amount of resources, you can build the SD-WAN lab offline as well in the EVNG platform. For example, PNet, you can build the online lab here in these virtualized platform as well. But the resource requirement is going to be a little bit on the high side. Minimum for a smooth operation, if you are going to deploy the SD-WAN solution in a virtualized environment, minimum for a smooth operation, you will require at least 64 GB of RAM. At least you should have a total of 16 virtual CPUs and at least like 500 GB SSD. SSD is needed if it is NVMe, if it is M.2 or NVMe, that is going to be better. But minimum this much amount of resources will be required for a smooth operation. You can practice on the older versions, like with less amount of resources, like for example, 32 GB RAM, 16 total like CPUs, and 500 GB like SSD. So you can practice on the lower version of the SD-WAN, even if you have like 32 GB RAM. But you can see if you refer to this. If you refer to that document, here is a document from the I-MEDITA website. Here is a document from the I-MEDITA website that describes, like, for example, how much amount of resources are required for each and every version. So, for example, if you are going to deploy the SD-WAN version 19 point something, then 16 GB RAM you will have to dedicate for the one controller, then 2 GB RAM you will have to dedicate for the second controller, and 1 GB RAM you will have to dedicate for the third controller. So minimum, if you see like 16 plus 2 is 18 and plus 19 GB minimum, 19 GB RAM is required for the controllers, and you will require like additional 5-6 GB RAM for the SD-WAN devices, vManage routers. So approximately in 32 GB, things might still work properly if you are practicing on the older version. But if you are working on the newer version, if you are working on the 20-point version, then you will require at least 24 GB of RAM, at least 20.x, 20-point version if you are practicing on, which is what is used in the production environment, 20.9, 20.10, for example, the stable release. 20.12 has become the stable release now. So these versions require at least 24 GB RAM here. So one of the controller will require minimum 24 GB. So 32 GB might not be sufficient. However, you can still build a small topology and practice on the same. But if you are going to go for the 20.12 or beyond, then you will require at least the 32 GB RAM for one single node. So having only 32 GB RAM will not be of any. That's why I said, like, if you want to deploy the lab in your home environment, then minimum for a smooth operation, minimum you will have to have the 64 GB, minimum 64 GB RAM, a total of like 16 virtual CPUs, and if 500 GB NVMe or like M.2 SSD is there, then it is going to work properly without any. If you can manage that much amount of resources in your desktop, or maybe you might have a server, you might get the server from your company, organization, whatever, like, if you can manage a virtual machine, if you can manage an EVE-NG with that much amount of resources, you can deploy the lab at your home environment. You can ask your account handler, they will connect you to the lab admin. Lab admin will take the remote access and they will deploy the lab in your, for example, environment for you. So you don't have to do anything. If you are familiar with like EVE-NG, how to do the deployment and all, then you can just ask them for the images and then they will do that as well. Otherwise, you can just ask the lab admin and then they will take the remote access and deploy the lab for you in your home. And I will recommend that if you can manage, I'm not saying that you have to, I'm saying that if you can manage at least for 15, 20 days, 30 days, for example, at least for 30 days, if you can manage this kind of like machine with this much amount of resources, I will say it will be much more better learning experience, because you can do the lab at whatever time. There will not be any time foundation or anything. You can do the lab at whatever time you want to. There is a WhatsApp group for the SD-WAN where you all will join and you can ask your question in that group and all. So plenty of like things can be done regarding that. So if you can manage this much amount of resources, then I will say that you must actually, so that you can have a better learning experience from the lab point of view. Else, you will be provided with the lab access from here. Online lab access will be there. That will be limited to 4 hours per day throughout the time period of our classes. And even after that, after like the class ends, I guess like 1 month, 2 months is there. You can get the confirmation from your account handler that for how many days after our class ends, the lab access is there. So they will let you know on the timings and all. So you can have all these kind of discussion with the management, with your account handler. But I will recommend personally, like if you can manage the laptop, desktop, or any kind of server for that, so like 30 days maximum, like, it will be better. If not, then you can just get the lab access from here as well. Both the options are. One will be time bounded. One is going to be like one, if you deploy things at your own environment, then it's not going to be there will not be any time. Right. So regarding the lab, like you can decide which one you want to opt for. Let me know. Any doubts in the lab section? Any doubts, any questions so far in the lab point? Anything you did not understand or any point that needs to be discussed? Let me know. Now, what is the lab? How will you get the lab file and all that? That I will let you know. I will tell you like how to get the lab and all that thing. So when we start our lab content, we will, since it's completely virtualized, since the lab is completely virtualized, so we do not need to worry about purchasing like any hardware also. We will not require to purchase like any kind of hardware or anything, since the lab is completely virtualized, since all the controllers and, for example, the vManage devices and everything, since it's completely virtualized, we do not need to purchase or download or any, hardware for the same. So this is our content that we will focus on. Whatever things say describe, we will describe. Whatever things say like implement or troubleshoot, we will do the practical implementation and troubleshooting of that as well. Also, like a few things that they say, for example, only describe, we will also do the practical implementation of those things as well. As much as possible, we will do the practical labs for these topics as well. So this is the content that we will follow, which will cover like 2 more contents, N4 and the CCI lab exam. The lab access, you will get the lab access when our lab starts, basically, which will take, I guess, like at least 2 weeks before we start our lab. For 2 weeks, we will have our technical discussion, theoretical discussion about the topics, and then we will start our lab afterwards, starting from the controller deployment, going all the way to the policies and everything. And then apart from that, like all the documentation, workbook, PDF, PPT, everything you will get on the portal, the Training portal from where you have joined the classes. There you will have various links on that portal. You will have various links from where you can download all kind of resources that are required for the completion of our training. So, for example, if you visit your course, under your course, you can just click on it and you can just download it directly. So you can just download it. This is the SD-WAN deployment getting started guide. It is officially from Cisco. So this is SD-WAN getting started guide that you can download and have it with you. So all the kind of like documentation and everything is already available with you on the portal. SD-WAN content. Approximately, it will take 24 to 25 classes. Approximately, I expect like 24, 25 classes will be there for our content. To be very honest, like I have not taken the SD-WAN batch in the weekdays for a very long time. So generally, it's like in the weekend, I do take the SD-WAN classes. So generally, it's like 10, 12 weekend like training. So basically 24, we will be able to complete like the content in 24, 25 classes here. Accordingly, in the weekends, it takes approximately 8 to 10 weekends. 10 weekends approximately it takes. So we will be able to complete it like approximately in 24, 25 classes. 2 hours per day, 8 to 10. 2 hours per day, approximately 24, 25 classes. I'm not saying days, by the way. I'm saying classes. Monday to Thursday. Friday, Saturday, and Sunday is going to be off. You can do the labs on Friday, Saturday. You can enjoy your Sunday, for example. So whatever things we do in these 4 days, you can do it in the weekdays as well, and then you can dedicate a dedicated day for the study, and then you can spend the weekend as per your choice. So Monday to Thursday classes will be there 4 days a week, 2 hours a day. And we will be able to complete it approximately in 24, 25. I believe, do we have any holidays meanwhile? Just to give you a heads up, I will let you know on any holiday.
The traditional networking is working, and
that is from where we will start actually. That is what we will start, like what is SD-WAN, why we need SD-WAN, how it is different from the traditional network, what are the traditional solutions. We'll talk about that in our technical content that will start like in just 5 minutes. We'll begin with that.
Oh, okay.
Yeah. Right. So so far, what we have covered, what we have discussed like what topics we are going to cover. This is again from the official Cisco website. These are the topics that we are going to cover. Then this is the lab environment that we will have. It is completely virtualized. Either you will get the lab access online from here, or you can just get the files and you can deploy it at your home environment. We will talk about the lab environment when we start the lab. But this is the lab topology that we will be working on, completely virtualized. We will have to only touch the we'll only have to touch the software defined part here, not the traditional part that we will discuss in our lab session. These are the labs that we are going to cover: creating the SD-WAN overlay underlay network, interconnecting SD-WAN components, installing the root certificate, initializing the controller, whatever, vManage, vBond, vSmart, whatever. Then vManage devices, initializing the vManage devices, registering the vManage devices on the vManage, performing the initial configurations on the devices, then deploying various templates, system, banner, VPN, AAA, BFD, configuring various basic templates, configuring routing templates, TLOC extension, whatever basically routing, whatever things we needed to do to make the reachability, we will talk about in all these small labs. Then the policies, different types of policies such as hub and spoke, traffic engineering, service insertion and chaining, route filtering, TLOC filtering, route leaking, VPN membership, preferred transport, application aware policy, NAT, DIA, CFLOT, QS, packet loss mitigation, application aware firewall, IPS IDS, URL filtering, AMP, DNS web security, cloud on ramp, whatever. So these are all the different types of policies that we will be implementing throughout our content. Then we will have a mix of policies. We will deploy a mix of policies to do multiple tasks at the same time. We will basically talk a lot about the policies in our content, the normal control policies, data policies, security policies, how security policies are implemented and all, we'll talk about all that as a part of our content. And then we will then we will start our day 2 operation. Day 2 operation basically means the management part. We will talk about at the beginning.
Sorry, you uploaded the topology in the portal?
No, the topology is not uploaded on the portal. Topology you can get from the lab.
Okay. Is it going to be single topology throughout the course?
No. It is just going to be a normal topology. This topology and in this composite topology, you are going to practice everything one by.
So it's like one topology for the entire lab, right? No.
Here all the traditional devices. Here all the traditional devices are pre-configured, and you will only need to focus on the SD-WAN devices and their deployment. The software version that we will be using, we will decide on the software version ourselves. There are a few challenges when choosing the correct software version to practice on. We will decide, together like which version we will have to practice on. I recommend 20.12 to practice on, but we will decide what are the challenges in that version. How should we choose the correct version to practice on? We will decide that later on, but just to be very brief, we will practice on 20.12 version of the SD-WAN.
Yes, for the lab, it's like the CCI lab.
CCI lab has 20.9 actually. CCI lab has version 20.9, but from the graphical user point of view, there are not many differences in 20.9 and 20.12. So Cisco basically, they changed the naming convention. Cisco completed the acquisition of the Viptela. There was a company called Viptela that used to provide the SD-WAN solution. So Cisco completed the acquisition of the Viptela around in August 2017. And then in June 2023, they rebranded the SD-WAN solution offered by Viptela to suit their portfolio. So from 20.12 release, they started calling the Viptela SD-WAN. They started calling the Viptela SD-WAN as the Catalyst SD-WAN. In one of the Cisco live event, Cisco is now connecting the power and flexibility of the Catalyst brand across the entire enterprise networking stack with the Catalyst Center, formerly the DNS Center, Catalyst software licensing, formerly the DNS software licensing, Catalyst wireless, Catalyst switching, Catalyst routing, and Catalyst SD-WAN. So formerly it was known as Cisco SD-WAN or Viptela SD-WAN. So they just changed the naming convention to Catalyst SD-WAN, and they made it effective with the release of SD-WAN version, software version 20.12. So they changed the name. They changed the name of the controller to a different name. They changed the name of the controller. They changed the name of the controller. Everything else remains the same. Just the naming convention they have changed. They have just changed the names. Rest everything, like how the SD-WAN solution operates and all that thing remains as it is. Remember that in the slides, if you see vManage automatically understand its SD-WAN manager, if you see like vMon automatically understand that it is validator, if you see vSmart automatically understand that it is controller. Consider the naming of the controllers in the slides being used interchangeably. So just the name has changed, nothing else. In the user interface, they have just changed the name. In a lot of places, you will still see the vManage, vBond, vSmart, but the naming convention has changed. The rest everything remains exactly the same with no changes at all. So why I recommend 20.12? Because you will get yourself familiar with the latest terminologies that they have. Effective 20.12, like all the other releases have the same. All the other releases have the same exact name and all. So I will recommend 20.12, even though in exam they have 20.9. And the latest version is 20.15. 16 is also there. So 20.12, 20.9, 20.15, or maybe 16, which version you will want to practice on, that needs to be decided. This is 20.12 is also now the recommended release for the production environment. 20.16, 15, they are still now not the recommended release. 20.9 is the one that we have in the exam. So conceptually, practically speaking, we should either go for 20.9 or 20.12. Since 20.9 and 20.12 they have almost similar user interface. They have almost similar user interface, with a lot of things being used interchangeably. So they almost have the similar user interface. So I will say this, using this 20.12 will be very much okay. But the major you will see that in 20.12 and 20.13 and beyond, there is a major change in the user interface. The user interface of 20.12 and the user interface of 20.13 is completely different. Completely different. So which gives us a challenge, like which version we should practice on. Should we practice on the version that is there in the CCI lab exam? Should we practice on the version that is recommended by Cisco for the production environment? Or should we practice on the version that is the latest version, or from where the user interface has started completely getting changed, 20.15, 20. So from 20.13, the user interface has changed completely. So we have like these three choices. So we will fix this issue. We will talk about the solution of this problem. But just to give you a heads up, we will practice on the 20. This is what we are going to use in our lab. Since 20.9, 20.12 has similar user interface, so you will not require the practice on 20.9. Once you have done practice on 20.12, then you can make yourself familiar by practicing on the upgraded version. Or I will give you one more solution. I will ask you to go to the D Cloud and see the differences between the releases 20.12 and later, and you can just navigate through the user interface from the D Cloud to see what option has been moved where and all. So that will also be sufficient, which we will talk about in our lab section, not here. But just to give you an idea, we will be practicing on 20, which will require a minimum 32 GB RAM for the one of the controller. So minimum 64 GB RAM for overall operation. Minimum 64 GB RAM you will require for overall operation, overall SD-WAN. If you can manage that much amount of resources at your home, it's good. If not, then you can get the lab access from here. You can drop a message to your account handler, and then they will connect you to the lab admin, and then they will ask you about the slots and all, and then you will get the lab access based on that as well. This is how we are going to do things. This is how we are going to cover our way. So traditionally, when we talk about like the traditional environment, we are talking about the WAN. WAN stands for like, wide area network. WAN is basically how we connect. Wide area network, or WAN, is basically how we connect our campus network with the rest of the branches, headquarters, data center. Assuming that we have here like VR1, here we have VR2, here we have some, for example, headquarter, here we have such as, for example, some data center, some small offices and all. So WAN typically defines how we are going to connect, how are we going to connect all these data center headquarter branches all together with the help of the transport. So we can provide the connectivity from the edge router that we have in our infrastructure. We can provide the connectivity with the help of the edge routers that we have in our infrastructure. We can have either one edge router, we can have multiple edge router. Some edge routers can be connected on the multiple transports, such as like internet, such as like MPLS. Some of the devices might be connected with only one of the transport. So we can have different options for this reachability. Once the reachability is there, once like this IP address is reachable with this IP address and this IP address and this IP address, once the reachability is there between all these devices, then we can decide to implement the additional configuration commands. We can decide to implement the additional technology, such as, for example, we might implement this VPN technology, for example, to secure the communication over the public network, such as internet. We can go for things such as VPN, we can go for GRE, we can go for like IPsec and whatnot. We can basically decide to implement different types of like protocols, configurations to secure the communication over insecure networks such as internet. WAN traditionally was focused more on connectivity, connecting basically different branches, headquarters, data centers, all together. WAN was more focused on connectivity. WAN was more focused on connecting all the WAN edge devices together so that the reachability can be provided from one location to other. To provide the reachability, we can use the concept of like GRE, VPN, IPsec, and other technologies as well to provide the connectivity from the LAN to the LAN, from the LAN to the LAN. We also had the option of using a private WAN transport such as MPLS. Internet is more like categorized as a public WAN transport. MPLS is categorized more like a private WAN services, private WAN transport. The main reason we call this MPLS transport as a private WAN transport is the reason because this MPLS transport internet is basically shared with everyone. Anyone who basically pays for the internet services can be connected to that public network, and they can use that network to send and receive the data. Internet is most probably the biggest network that you can ever find. So internet is more like a public network. Anyone can connect to the internet and they can start sending and receiving the data. All you need to do is just a capable device, and you can connect yourself with the internet services, and then you can start sending and receiving data. However, the use of MPLS or multi-protocol level switching, using the MPLS technology also, we can provide the connectivity between these IP addresses that are available on our vManages. So using the MPLS transport, which is more like a private transport. Not everyone gets their hands on the MPLS transport. It's more like private to those who have subscribed, who have opted for this kind of solution. It's like the MPLS service providers, they have their own set of wires, cables that can provide the connectivity between all these locations over some sort of like private way, in more like a private way, rather than having accessible to everyone. Only those who have more like subscribed, only those who have, for example, opted for the MPLS solution can get this kind of connectivity also. The objective was to provide the reachability. The objective of the WAN was to provide the reachability between all these IP addresses. Once the reachability was there, then we can use various protocols to exchange our routes from one location to the location. And once the route exchange process was done, we can use the transport such as MPLS or internet to send and receive our traffic over insecure public network, over a private network that people used to consider a little bit more secure as compared to internet. By the way, there is no security in MPLS. There is no security in MPLS. The only reason why they say that MPLS is much more secure as compared to the internet is basically the fact that it's not shared with anyone. It's not like shared with every. It's not shared with every. Only those who have subscribed for this MPLS connection, they only get their hands on the MPLS technology. Not everyone can just come and then start sending the data over this MPLS. But that's why in an essence, that's why this MPLS is more like a private WAN transport rather than a public WAN transport. Connectivity between different devices can be done over a public WAN transport such as internet, and connectivity between the devices of different locations can be done over a private transport such as MPLS. The major difference between them is the this sense of security. MPLS is considered more secure as compared to the internet in sense that it is not shared with everyone like internet. But still, whatever data we send and receive over the MPLS transport, it's not encrypted. It is not encrypted. It is not secured by default. So there are still very much possibilities that when you send some data over the MPLS service provider, chances of attacks, chances of data theft can still be there. It's not encrypted. It's more reliable than internet. It is costlier than internet as well. It is more costly than internet as well. So there are a lot of things associated with the MPLS transport, such as cost, such as the availability, such as reliability, such as security. There are a lot of things based on which because of which based on in the traditional environment people used to prefer. In the traditional environment, people used to prefer this MPLS as their primary transport to send and receive. If you want to enforce the security, by the way, we do have the option. In the MPLS, we can implement the VPN, such as get a VPN. Group encrypted transport virtual private network designed specifically to secure the communication over the MPLS network. Some additional configurations might be required for the same. But even if you don't configure this get VPN, since it's more like a private WAN transport, sense of security is there as compared to the public transport such as internet. What people used to do in case of public transport such as internet, they used to build these secure communication channel over this transport. People used to build the secure communication channel over these over this internet transport. People used to build tunnels, GRE, DMVPN, these kind of tunnels people used to build over this insecure transport such as internet, and then they used to secure the communication. They used to secure the communication over these tunnels with the help of a protocol called IPsec. Requires manual configuration of these tunnels, require manual configuration of our security protocol so that we can send our private data from one point to the other. So basically MPLS was your preferred transport. MPLS was your preferred transport by multi-protocol label switching. MPLS was your primary transport, and internet we used to use as a DMVPN. Internet we used to use as a VPN. Internet we used to use as a secondary. Just because that it gives you a sense of security in some sense, we used to use MPLS as a primary transport based on reliability, availability. In a way, it's private WAN transport. So because of a lot of reasons, we used to use MPLS as our primary transport and internet as a secondary transport. Then we also have this concept called 4G LTE. Nowadays, we have 4G long-term evolution, 4G LTE. Nowadays, we also have this concept called Metro Ethernet. Metro Ethernet is where the connectivity in the metropolitan city is provided solely based on the Ethernet technology. So companies can install their fiber optical cables from one end of the city to the other end of the city, and they can provide the connectivity everywhere. So Metro Ethernet concept is also there. There are different types of WAN transports that are available nowadays. But again, the traditional WAN was focused more on interconnecting multiple devices. The traditional WAN was more focused on interconnecting all the devices together. Then came the concept of cloud. Then came the concept of the software-defined networking. There came a lot of additional things in the market. IoT devices, for example. Humans were no longer only user of the network. We now have like the IoT devices. We have different types of like sensors, cameras, and all that. They also became the users of the network actually. So basically, so one of the biggest challenge was adoption of these new things that were coming in the market, such as IoT, such as cloud, for example, such as IoT, such as cloud, and these kind of things. So addition of these, made WAN a little bit more complicated to handle. Moreover, like things started moving. Moreover, things started moving to the cloud. Earlier, applications were deployed. Earlier, applications were deployed onto the premises. But nowadays, like applications are hosted on the cloud. Nowadays, applications are hosted on the cloud. So how the traditional WAN is going to address the challenges, latency, drops, and all these things, how the traditional WAN is going to address the challenges regarding these things. Those things might require manual configuration. Companies started moving their infrastructure to the cloud. Companies started deploying cloud-delivered firewalls, cloud-delivered data center. How are we going to extend the connectivity of our branches to these cloud-delivered solutions, such as firewall, such as data center? How the user experience can be improved for those? How can we deploy the policies on the cloud-delivered firewall and redirect our traffic of branch 1 to branch 2 via that cloud-delivered firewall, and then to this point? Let's say you have to deploy like a new branch. In that new branch, let's say you have to deploy 2 vNS devices. And both the vNS devices need the connectivity with the internet and the MPLS transport. So we will have to do certain configurations on this vNS router, provide the connectivity with the internet to the MPLS, configure the policies, configure the VPN settings and all those things. When we have to deploy a few new devices in a few new branches, then the configurations are needed to be done manually. Even though you might use tools, you might copy and paste the configurations from one of your branch to the new branch, but that will also have a risk of pasting the same configurations without changing the values. If you accidentally paste the same configuration that we have done on one of the branch on this newly added branch without changing the expected values, then also there might be issues. All the traffic that must have gone to this branch will now somehow started going to that branch maybe. There could be like various challenges even if you do the copy paste, then also like deploying a new device will add like a lot of challenges. Let's not even talk about the troubleshooting. Let's say, for example, a few branch users are experiencing packet loss. A few branch devices are experiencing the packet loss, and for the other branch devices, everything is working as expected. For a few branch devices, they are experiencing the packet loss, and for the rest of the branches, everything is working as expected. So we need to log into the vNS devices that are connected onto that branch to run some commands. And after running those commands, we will be able to understand. We will be able to see what exactly, we will have to execute some commands basically. And then after we will be able to find out the issues and all. And then we will be able to resolve it. Basically, the issue resolution will take like some time as well. The issue resolution will also take like first when the issue was reported versus when the issue was resolved could take a significant amount of time. Basically, overall, that you will need to spend money on various troubleshooting tools, various management tools, so that you can manage your entire WAN network from, for example, one centralized point. Total cost of operating the network was higher. Total cost of operating the network was higher. The operations to manage the traditional network was complicated. We need to configure like configurations regarding the VPN, DMVPN, IPsec, get VPN, XYZ, do the configuration here, then here, then here, then here, so that the connectivity can be there. Manual configurations are complex to manage. There are always chances of some issues. If you add like a few more transport, then it will be hard. It will be difficult to manage those multiple transports, define priority of one transport over another, define that some traffic must go via this transport, however, some traffic must go via this transport, configuring the policy on n number of devices, one by one, to prefer one transport over another to address the loss or address the latency issues on the transport will be difficult to manage as well. When we have to provide the internet connectivity, earlier in the traditional WAN environment, we are not going to deploy a security appliance on every branch. I am not going to deploy a security appliance on every branch. Instead, what I'm going to do, instead of that, I am going to deploy my security appliances. Instead of that, I'm going to deploy the security appliances in the data center. Instead of that, I am going to deploy the security appliances on the data center. And then we are going to redirect all the traffic. We are going to redirect all the traffic from the branch to the data center. Even if the user wants to access the internet, user wants to access those applications delivered on the, deployed on the internet, infrastructure as a service, software as a service, the infra that is deployed on the cloud, the software that are deployed on the cloud. Even if the user wants to access these infra or infrastructure as services or software as services, it has to send all the traffic to the data center where the inspection will happen based on the security plans that we have deployed. And then the traffic will go to the internet. Then the traffic will go to the infra that is delivered on the cloud. Then the traffic will go to the softwares that are deployed on the cloud. Basically, the user experience will be very poor because all the traffic is getting delivered via the data center. So some latency, even though the security is there, but since we are redirecting all the traffic to the data center, which was our priority, and there the inspection and everything will happen, and then the traffic will reach out to those cloud delivered infrastructure, cloud delivered applications, or even the internet. It will result in a poor user experience. Managing all these n number of devices that are deployed in n number of branches in n number of geographical locations, doing the SSH on all these branches over the internet, and then running the configuration commands and all, managing each and every device like one by one, it is also going to add it will also add an additional challenge in the management. If we have like way too many, like for example, branches, then it might not even be very scalable to manage all those devices one by one locally by doing the telnet SSH. So localized management we are going to have here in the traditional or legacy wide area. We will need to involve in the routing process with the service providers, like such as we are going to run BGP, we are going to run OSPF. In the LAN, we are running like OSPF. In the LAN, we are running like EIGRP. So we will need to redistribute EIGRP into OSPF, OSPF into EIGRP, XYZ. We will need to perform complex routing operations so that like our routes can be advertised from like the branch to the data center, from the data center to the branch, so that the reachability can be ensured. In protocols such as BGP, you might need to perform path manipulation, traffic engineering, which is going to add an additional layer of challenge. Traditional WAN is not application aware, or it has a limited application awareness. So for example, if I want to configure a policy in such a way that our business critical application traffic must go over the transport that has a low loss, latency, and jitter, we will need to either use some tools to observe out of these multiple transport, which of the transport has lowest packet loss, delay, latency, and jitter. And then based on that, we can configure this device to prefer one path over another. Traditional WAN is not that much application aware. Traditional WAN, legacy WAN, lacks the application visibility. It has a limited app awareness. So it might not be possible that, or it might be complicated to manage the policies based on your certain applications, such as business critical applications must follow like one path over another. That kind of policy, if you want to implement, it will be hard to implement that kind of policy in the traditional or legacy wide area network. Apart from that, other challenges are there also, which we will talk about. But connecting the users to the data center was the priority. So all the traffic used to go via the data center in order to access the internet, in order to access those cloud delivered application infrastructure and the application, which added additional like latency delay, resulting in poor user experience. Traditional WAN was not aware of the application. So if you want to deploy a policy around your business critical application, it might not be possible to deploy because your traditional WAN is not even aware of that application. We might need to advertise our routes using some routing protocols over the WAN, so that like everyone learns those routes and then we'll be able to send and receive the data. So routing might get a little bit complicated. Performing the routing between the branches, data center, headquarter, and all might get a little bit complicated. Each and every device needs to be managed locally, which is not a very scalable solution. In a large WAN environment, in a big WAN environment, it might not even be possible to deploy, or manage all these WAN devices one by one. If you have multiple transports, preferring one transport over another based on various characteristics is also going to be difficult. How to prefer one transport over another, that is also going to be a challenging part. Basically, overall WAN operation is complicated, complex, and total cost to operate the overall legacy WAN is going to be very high. Apart from these general challenges, we also have a few more challenges that we will talk about. We'll talk about a few more challenges, and then we will see what has changed. So we were talking about different challenges that we had in the traditional network, such as in the traditional network, our priority was to connect the users to the data center, because typically we used to place our security appliances at the data center. All the traffic will be redirected towards the data center, where it will be inspected via those security appliances, and then based on the policies, either they will be allowed to reach to the internet, they will not be allowed to reach to the internet. Then they will be allowed or not allowed to access those cloud delivered applications, cloud delivered infrastructure. Every device, peer-to-peer, forget about it. Lack of application visibility. The traditional WAN, the legacy WAN that we have, it is not application aware. So not application aware basically means that, or limited application visibility basically means that the modern day applications that we deploy on the clouds or the applications that we are running in the data center, the legacy WAN, the traditional WAN is not aware of those application services. Meaning to say that if I want to prioritize one transport over another transport for certain application traffic, that might not be possible when it comes to the legacy WAN until we run some dedicated additional commands to match the traffic based on the port numbers and all. So the traditional WAN or the legacy WAN is not application aware. It lacks application visibility. We need to involve ourselves in the routing process with the service provider or with the other branches, with the data center. We might choose to use routing protocols such as OSPF, EIGRP, or maybe border gateway protocol. Based on that, based on that, we are going to form the EIGRP, OSPF, BGP neighborship. Then we are going to exchange the routes, and then the traffic will start flowing. All the device needs to be managed one by one, which might not be a very scalable solution. If you have multiple transport, supporting the multiple transport, giving some sort of preference to one transport over another is going to be a challenging task. Overall, basically the legacy WAN operation was complex, and total cost to operate the network was actually very. Traditionally, basically, when we talk about these traditional devices, the functionality of a device can be broken down into three parts. One is like the control plane functions, one is the data plane function, and one is the management plane. From the architectural point of view, I can divide the functionality of the device into three major architectural planes. Three major architectural components are there. One is the control plane, one is the data plane, one is the management plane. Control plane, data plane, and the management plane. Control plane functions, data plane functions, and the management plane functions are performed by the device. Whatever operations device perform, whether it's forming the EIGRP, OSPF neighborship, exchanging the routes, performing encapsulation, decapsulation, allowing the user to access the device via telnet, SSH, all these functions that the device performs, they can be categorized as the control plane functions, data plane functions, or the management plane function. Management plane functions or management plane of the device. Management plane of the device is responsible to provide the management level of access, how the device is being managed. How are we managing the device? Are we using telnet, SSH, console, auxiliary? Are we using like CCNP? What kind of what approach we are using to actually manage that particular device? That is handled by the management plane of the device. The part of the device that handles management function is referred to as the management plane of the device. Essentially, when we set up the console password, when we set up the VTY password, when we set up the auxiliary password, when we set up the credentials for the CCNP and all, eventually, like what we are doing, we are securing our management plane. We are securing that not everyone can get the access of the device. Only the authorized, authenticated users are allowed to get the access of the things such as encapsulation, decapsulation. When the data arrives, the data will be decapsulated. Then the routing table lookup will happen. Based on that, the router will determine what is the exit interface, and it will place the data onto that interface. Then while placing the data, encapsulation will perform. So things such as encapsulation, decapsulation, routing table lookup, MAC table lookup, RF cache table lookup, all these kind of functions, all these functions that are involved in order to perform the data forwarding, all these functions are called data plane functions. All of these functions are referred to as the data plane functions. Data plane functions are those functions. Data plane is the part of the device which is responsible to perform things such as encapsulation, decapsulation, and various table lookups, so that it can decide like where to forward the data. So when the packet arrives on the interface and the packet is decapsulated, typically it is the data plane functionality to decapsulate the packet. Then when the routing table lookup happens, it is the data plane functionality to perform the routing table lookup. And when the packet is placed onto a certain exit interface, while the packet is getting placed, encapsulation needs to happen again. So that functionality is all of these functions are the data plane functions. And who is responsible to maintain these tables? Who is going to create these tables, such as routing table, ARP cache, such as, for example, your STP, spanning tree database, and all those different types of tables that the device can maintain in order to perform the data forwarding? It is the responsibility of the control plane. It is the responsibility of the control plane to create various tables, such as routing tables, such as ARP cache, such as the MAC address table, for example. All these kind of tables that are used by the data plane to perform the packet forwarding. Control plane controls the data plane. Control plane is the one that is responsible to instruct the data plane about like how to forward the data. Control plane creates the tables. Those are referred. Those are checked by the data plane. So eventually, like if there is an entry in the routing table, the packet will be forwarded. If there is no entry in the routing table, then the packet will not be forwarded. So control plane controls what packet can be forwarded out of what interface and all, by creating, by populating, by making various entries in some sort of tables. When we say that two routers are going to form the OSPF, GRP adjacencies, they are going to exchange the routes and all, topology database, BGP update, STP messages, OSPF messages, all these messages are created and sent by the control plane of the device. Control plane basically means, the CPU, the brain of the device, responsible to perform, maintain, create like all these different types of tables. So every device has the control plane functions, which is responsible to create various tables that will be referred by the data plane in order to perform the actual data forwarding. And then the management functions can be performed by the management. Control plane, data plane, and management plane. These are three functions that we have here. And these three functions are in fact performed. These three functions are in fact performed by the legacy devices. Now, in the traditional architecture, whether we are talking about LAN or WAN, in the traditional architecture, we have distributed control plane, data plane, and management plane architecture. Every device has its own set of control plane, data plane, and management. So if two devices are supposed to perform the data forwarding, these two devices first must, for example, run some sort of routing protocol. Then they will exchange the routes. Then they will update their routing table with those new routes, and then the forwarding basically will happen. So routing process and then the forwarding process. Routing process is basically responsible to create those various tables that can be referred to by the data plane in order to forward the data. And forwarding plane is actually responsible to forward that. So this device has its own set of management plane. This device has its own set of management planes. So if you want to access this device, you can use telnet, SSH, console, auxiliary, and you can then access this device either like locally or via remote. Once you are done doing the configuration on this device, then you will disconnect your console, terminate your SSH session, and then you are going to connect yourself to the second device. Basically, if you want to configure all these devices, since every device has its own set of management plane, we will need to take the access of each and every device individually, and we are going to configure those devices one by one, box by box basis. Since every device has distributed management plane, which means basically every device has its own management plane, means that if we want to configure the device, then you will have to take the access of the device like one by one and do the configuration on each and every configuration, such as we are going to configure OSPF here, we are going to configure OSPF here. So we will take the access of the device first, configure OSPF, then we will take the access of the device, and then we will do the OSPF configuration. And then OSPF messages will pass between the devices. OSPF messages will pass between the devices. Those control plane messages, OSPF control plane is going to generate some OSPF messages. Those messages will pass between the devices. They will form the OSPF neighborship. They will exchange the database, and then they will calculate the routing table. They will basically update their routing table, and then the data forwarding between the two devices will happen. Every device has its own set of control plane, management plane, and the data plane. That is why each and every device must be configured manually, one by one, box by box basis. On each and every device, we will have to configure a protocol, control plane protocol, such as OSPF. Each and every device must maintain their own set of tables that can be looked up by the data plane when the forwarding needs to take place. Yes, let me know.
Yeah, as a quick question. So when we are talking about the control plane, data plane, and management plane, in which part of the routing and switching this happen? I mean, it's RAM, disk, where it's happen?
No, it's basically like, for example, the control plane operations are CPU centric operations. So when we talk about the control plane, eventually we are talking about the CPU of the device. When we are talking about the data plane, a data plane basically refers to the process of performing things such as decapsulation, encapsulation, routing table lookup. Now, routing table, ARP cache, all these tables are populated in the RAM of the device. So management plane functions are basically the functions that are performed by the device to provide the management level of access. So, both like RAM and CPUs will be involved of the device to perform these control plane, data plane, and the management plane functions.
So when we set up the switch or router, so do we need to specify the amount of space they have to use?
No.
Particular? No. Okay. Is it randomly
you will just set up the telnet SSH. You will just set up the routing protocol such as EIGRP, OSPF. The devices will form the EIGRP, OSPF neighborship adjacencies, and then they will use whatever amount of bandwidth CPU resources are available. We can limit in some protocols. We can limit the amount of resources they can consume, but other than that, we do not define these kind of things. We let the device choose automatically how much resources they can consume in order to make things work.
Okay. Right. So it's a combination of RAM and CPU.
Correct. RAM, CPU, the mostly like the information is maintained in the whatever things are running on the device is maintained in the RAM. The instructions are given by the CPU. So yeah, things are performed by the RAM and CPU of the device.
So once we have some performance issue on the switches, routers, do we need to check these three components, or how we are going to troubleshoot? I just need to correlate with the utilizations of these.
Those things are more like from the monitoring point of view. So if you are experiencing like high CPU utilization or high memory utilization, on the device, you can execute the commands to find out like which process of the device is consuming like more CPU, more RAM, and then you can either terminate that process or maybe optimize that process accordingly. You can do it with the help of the commands, or you can do it with the help of some monitoring tools that your company might be using.
Okay, thanks.
Show processes CPU, for example, is one of the commands. Show processes CPU history, for example, show processes CPU utilization. A few commands are there that you can use to check these utilization. But these things are more like from the routing point of, or maybe the switching point of. These are more like the hardware specific.
I got it. Thanks.
So basically, in the traditional network architecture, every device has its own set of like control plane, data plane, and the management. Since every device has its own set of management plane, if we want to perform the management of the device, you will need to take the access of this device, do the configuration, then you will need to take the access of this device, then do the configuration. Those things you will need to do one by. So management plane functions are the functions performed by the device to provide the access of the device to the user, so that the user can perform the configuration of, for example, protocol OSPF, so that OSPF can form the neighbor table, database table, routing table, updates the information in the forwarding table so that the data plane can decide how to forward the data. Key point here, we are not going to talk about the routing. The key point here is that every device has its own set of management plane, control plane, and the data plane. So each and every device needs to be configured, accessed, managed one by one, box by box basis. On every device, we have to configure a protocol so that the information about the subnets can be exchanged, and every device will take a look at their own table to decide how to forward the packet respectively. So if you have like a lot of devices, if you have, let's say, for example, a lot of devices, accessing and managing all those devices, one by one is going to be a complicated task. So overall, like if you have many branches, in many branches you have many branches in many networks, many geographical locations, and in every branch you have at least, like for example, one or two vManage devices. Accessing all those vManage devices one by one, managing all those devices one by one, it is going to be complex to operate. It is going to be difficult to secure, and overall user experience is going to be poor, because every traffic needs to be forwarded. Every traffic needs to be forwarded to the data center. So security related challenges are there, limited app awareness, no cloud ready WAN, high cost, complex operation. The modern day applications are consuming, the modern day applications that we have. Let's take a very basic example, like for example, Chrome, or any other your business critical application or any kind of application which can consume a lot of bandwidth. So the bandwidth might not be sufficient for all the applications. They decided to use some sort of approach to manage all these things in more like an automated fashion. In the data center network, however, this concept called software-defined networking, where the administrator, instead of accessing all the devices one by one, administrator will interact with the application with the help of a software. Where a piece of software actually, in case of software-defined networking, what happens? A piece of software will configure the network in an automated fashion. So if we have n number of devices in n number of geographical location, and you want to manage all those devices, instead of managing all those devices one by one, we can use some software that will configure. We will interact with that software. We will define our intent, what exactly we want to achieve from the network, rather than configuring the network on per device basis. There was a concept called intent-based networking, where the administrator, intent-based networking basically means where the administrator will define its intent, what exactly they want to do, what exactly they want to achieve with the help of some software. And the software is going to configure, software is going to take that intent, software is going to convert that intent into some configuration, and the software is going to push all the necessary configurations on those devices. And this thing was not new actually. In the data center environment, in the DC environment, in the data center environment, this thing was very popular in earlier days as well. The concept of WAN will be there in the data center, in the service provider, in the like, enterprise. So the concept of WAN, wide area network, will remain like common in all the locations. So what has changed actually, the enterprise network has now a greater demand for mobile, Internet of Things, IoT traffic, SaaS application, infra as a service, cloud adoption, security requirements, application requires priority optimization. The problem is that as compared to the traditional wide area network, current WAN is evolving to manage these challenging application landscape. There are more user requirements nowadays in modern day WAN as compared to the older or legacy WAN. Not only more user, but more types of user. Earlier, humans were the only users of the network, but nowadays we have like IoT devices such as CCTV camera, we have smart home devices, appliances, and all that thing. So not only humans, but we nowadays have the devices communicating with the devices. Devices also have become the user of the network. Earlier, humans were the only users of the network, but nowadays devices also have become the users of the network. An application might want to communicate with another application. An IoT device which is supposed to export the traffic, or which is supposed to like generate some sort of like alerts when certain thing happens. So the device needs to be connected to the network as well. And if the device connects to the network, it will get an IP address, subnet mask, default gateway. If it is part of the network, then we will also have to manage the traffic sent by that particular device. So not only more users, but more types of users. Different types of users also have come in the network. Not only the users, but different types of users also are there in the network. And we should do some configurations in order to separate our, for example, corporate user traffic with the guest user traffic, and with these like IoT or different types of devices. We will need to do something to achieve clear separation, so that the corporate users cannot communicate with the guest users cannot communicate with the IoT users. So we will need to enforce some sort of security in order to provide proper communication between the different types of devices, different types of users. Applications that we used to deploy on the premises, on the laptop, desktop, they are moving to the cloud. For example, like Office, Microsoft Office. Earlier, we used to purchase and install the Microsoft Office on our local machine, but nowadays we do have the concept called Office 365, where we can take all the benefits of the Office from the cloud. We don't need to install this on our premises. We can just use the Office services. We can use this Office software as a service from the cloud. Of course, we need to subscribe. We need to pay a certain amount of money, but we can do it. Google Drive, for example, Dropbox, for example, CRM application, for example, that your company might be using. Applications that we used to install on our devices, or maybe our like data center headquarter, the applications are moving into the cloud. More and more applications are moving into the cloud. In fact, there is a concept called born in cloud. There is a concept called, someday when you study like cloud networking, you will see there is a concept called born in cloud. Basically, an application is completely like developed, completely like created in the cloud infrastructure itself. It is supposed to be deployed only on the cloud, not on the premises, for example. SaaS, software as a service, basically. Softwares that we used to run on our machines, they are running as a service on the cloud. Companies are moving their infrastructure to the cloud instead of having like a big infrastructure on their premises, like having to purchase like different routers, switches, like servers and all. They can just get the subscription from the user providers that can run all these things on the cloud. So infra as a service. Infra as a service basically means companies are running their infrastructure on the cloud nowadays. Cloud delivered firewalls are there. Cloud delivered security appliances are there. Cloud delivered routers are there. Cloud delivered security, cloud delivered firewall. These are very common concepts that we see in cloud delivered data center, where we can store things, store or provide the services to the users from the cloud. So applications are moving to the cloud, and also not only one cloud, multiple clouds. Some applications companies deploy on the AWS, some applications they deploy on Azure, some applications they deploy on GCP. not only one cloud. If it was one cloud, candidate can learn one cloud and get to know about it. But companies are deploying their services, infrastructure, and all that thing on multiple clouds, whatever fits their business needs. They are deploying the services, applications on multiple clouds, not one, multi-cloud. Companies have their own data center also. So in that data center, they might be running some business critical applications. But for other general applications, they might use the public cloud services provided by AWS, Azure, GCP, or any other cloud service provider. SaaS, software as a service, infra as a service, these are very popular trends nowadays that we have. Softwares are moving to the cloud, infra is moving to the cloud. Branches no longer needs to send all the traffic to the data center and from there access the internet. The concept of regional or central breakout, regional internet access or central breakout. Central breakout basically means from a centralized location, we are providing the internet reachability. That concept is going away as well. Branches are getting nowadays called DIA. DIA stands for direct internet access. Why? So that when the branch user sends some traffic for those cloud delivered application or cloud delivered infrastructure, the traffic exits the branch locally instead of going all the way to the data center and getting the access. The branches can now access those cloud delivered, for example, applications and infrastructure locally as well. Reducing the latency loss, improving the user experience. Actually, improving the user experience was the objective. So in some branches, you might have this concept called DIA. However, in the other branches, you will still have that central breakout or regional internet access. Applications are moving to not one, but many cloud. Earlier, we used to go to the office and access our office infrastructure, or we used to access the applications from the office itself. But nowadays, we have this concept, very popular concept called work from home, where candidates can access their resources from anywhere at any time, from anywhere or any time they can access the company resources. Users are not, or the users of the network are not supposed to go to the office always. They can do things such as work from home and all. Basically, now how your traditional wide area network is going to address all these challenges, how your traditional WAN is going to address the challenges of different types of user, how the traditional WAN is going to address the challenge of applications moving to the cloud, how the traditional WAN is going to improve the user experience for those applications that are getting deployed in the cloud, how the traditional WAN can be connected to those SaaS applications or infra as a service, infrastructure as a service, how the traditional WAN is going to enforce the security when we provide the direct internet access, how it is possible that we can access the network anywhere, anytime we want, and still be able to have proper security, have the access of the network, how the traditional WAN is going to, connect to those different cloud service providers, AWS, Azure, and all, and how can it improve the user experience for the infra or software deployed on those clouds. There were like a lot of challenges. Earlier, when the objective was WAN was just to connect multiple branches at quarter all together, it was easy, but things have changed rapidly, like different types of user came in the market, the concept of the smart city, smart home, CCTV cameras, and all these smart appliances and all these things came in the market. Cloud came in the market. So different like technology, since the network is ever evolving, because of these different types of challenges, the traditional WAN also needs to evolve, or traditional WAN needs to address at least all these challenges that we are facing. Our traditional WAN must be ready to face all these challenges. Our traditional WAN must be configured in such a way that it can address all these challenges at minimum. Same challenge that we were facing from the WAN point of view, same challenge we were also facing from the LAN point of view. In the company, in the enterprise local area network, we have a lot of devices, and managing all these devices one by one is also going to be a time-consuming task. Configuring all these devices one by one, enforcing the policy, security, and everything one by one, it is also going to add additional challenges. In the data center environment, that is a data center which is centric to certain applications that are running in that data center. Data centers are those facilities that provide different types of services to the user. Service such as storage or maybe some business critical applications might be running in that data center. Data centers are built around certain applications that they serve, hence the name application-centric infrastructure. How are we going to manage the data center infrastructure? How are we going to manage the WAN infrastructure? How are we going to manage the LAN infrastructure? If we have to do all these things one by one, if my company has all these three things, LAN, WAN, and the data center, my company has like 10, 20 branches. In every branch, we have 2 vManage devices. Then like we have some LAN devices. Then we have 2 data centers, 1 main data center, 1 recovery data center. So managing all the devices one by one is going to consume a lot of time. Configurations might be prone to error. Even if you just copy and paste, the configurations from one device to the other device, the configurations still will be prone to errors. You might unknowingly copy and paste incorrect configuration from one device to the other device. So in the data center network, everyone basically, everyone then came up with the idea, why don't we introduce, we are already using different types of software in our organization to manage our network. We might also be using the softwares to configure the network. So they thought like, why don't we create some software? Why don't we create some softwares that will be responsible to manage the campus local area network? Why don't we create some software that will be responsible to manage the wide area network? And why don't we create some software that will be responsible to manage the data center infrastructure? So the engineer, they don't need to interact with all these LAN, WAN, or data center devices one by one. The engineer will need to interact with the software. The engineer need to define their intent on the software, and the software is going to program. The software is going to do whatever configurations that are needed to be pushed onto the devices to make your intent work. And then we will deploy this software on some sort of hardware. Of course, like in order to run this software, we will require some hardware. So we will deploy this software on some sort of hardware. This hardware will run that software, which is responsible to manage, configure our campus LAN, WAN, and the data center network. And this hardware is what we are going to refer to as the network controller, or simply controller. Network controller. Network controller is basically a device that is responsible to manage the network infrastructure, manage the campus LAN, campus WAN, and campus maybe the data center network as well. So a hardware that is running some sort of software responsible to manage the campus LAN, WAN, and data center network is what they refer to as the control. How much control? What things can be controlled? How much control is our data plane, control plane, management plane? What degree of control? What degree of control we will get? That depends. What degree of control that we get? Will we be able to do like everything from the controller? Or we will be able to just do the management and rest of the things we will need to do like manually on the devices? What degree of control we will get? That is completely dependent on what controller we are talking about. In the data center network, they created, to overcome these challenges, they decided to use software-defined approach to manage the network, where the engineer will not interact with the devices. The engineer will configure its intent, and the software will automatically configure the devices based on what intent the engineer has configured. Basically, network-wide configuration rather than per device basis configuration. Configure the network rather than configuring all the devices. Different vendors, they used to offer different solution. Nowadays, also different vendors are there, and they offer different software-defined networking solution. SDN, different SDN solutions are offered by other vendors. When it comes to Cisco offers three main like SDN solution to manage the campus network, data center infrastructure, and all. So they offer like 3 automation. They offer 3 software-defined networking solution. Open Daylight controller based on Open Daylight controller based on Cisco Open SDN model So Open SDN controller or Open Daylight controller, they used to sell this controller earlier. Nowadays, it has gone obsolete. So you will not see the use of this controller, Open Daylight controller, or it was based on the Open Network Foundation. So, Cisco added some specific commands or specific things to this solution, and then they started selling it. But sooner, like they removed this, they no longer sell this Open Daylight controller based on like OpenSDN solution. So it has gone obsolete completely. So you will not see the use of this. In the data center infrastructure, ACIE, application centric infrastructure for DC, ACIE for data center. Application centric infrastructure, ACIE data center. Build the data center around the application that they serve. Configure the data center around the application that they serve. Application centric infrastructure for the data center network. And the controller that is responsible to manage the ACIE data center was named as EPIC. EPIC stands for Application Policy Infrastructure Controller. Application Policy Infrastructure Controller, EPIC. EPIC, ACIE, EPIC. ACIE is the data center solution, and EPIC is the name of the controller, Application Policy Infrastructure Controller. It is still used in the Cisco data. It is still used in the Cisco data center environment. You will still see the use of ACIE and EPIC in the data center network in order to manage the data center network in a software-defined approach, rather than configuring all these things one by one. Maybe someday when you go for the data center track, you will learn about the ACIE EPIC concept. Not here, of course, but the ACIE data center. The data center can be managed in a software-defined way, in a software-defined approach, with the help of this EPIC, Application Policy Infrastructure Controller. This EPIC became very popular. This EPIC controller actually became very popular. More and more like companies started adopting this EPIC, Application Policy Infrastructure Controller, for their data center infrastructure, for their data center environment, and it became like very, very popular. It's still in a modern day network. Still, if you are building the Cisco data center, you will see the use of ACIE data center, ACIE and EPIC. In modern day network also, this solution still remains well. In fact, it became so popular that they decided to create an enterprise version of the same controller. They decided to create the enterprise version of the same controller, and they called it like EPIC EM, Application Policy Infrastructure Controller Enterprise Module. EM stands for Enterprise Module. So for the enterprise network, they did create this EPIC EM. Just give me a second, guys. Just give me a second. Application policy, the EPIC EM, Application Policy Infrastructure Controller, based, inspired from the EPIC, inspired from Application Policy Infrastructure Controller. They created an enterprise version. They created an enterprise module. This was a different controller. EPIC was a different controller, and EPIC EM was a different controller. Unfortunately, this EPIC EM could not gain that much popularity, and they no longer sell this controller as well. So the only controller that you see for the data center infrastructure is the ACIE EPIC. EPIC EM, the enterprise module of the same controller, is no longer present in the network. They redesigned it, or they repurposed it, and they launched it with the name of like later on when the software defined networking became popular around in like 17, 18, 19, then they rebranded it, they repurposed it, and they added a few features in this EPIC EM, and they created a new controller called DNA Center, Digital Network Architecture DNA Center, also known as nowadays Catalyst Center, which is used in Cisco SD-LAN or SD-Access, whatever you call, as the software-defined local area network. Cisco calls it SD-Access. Other vendors call it SD-LAN. So when we want to manage our LAN devices or local area network devices such as switches with the help of the software-defined approach, we are going to purchase and install this controller known as the DNA Center or the Catalyst Center. Again, it is gaining a little bit popularity nowadays. A lot of companies are using this controller in their production environment. They are adding new features in this DNA Center or Catalyst Center controller. The base of this controller still remains EPIC EM, and they added a few more functionalities in this Epic EM when they rebranded, repurposed this Epic EM with the name of like DNS Center or Catalyst Center, which is a very popular solution for the SD access or campus local area network. For a CAN, for a campus area network, it is very. So for the data center, we have Epic, Application Policy Infrastructure Controller, which works based on ACI, Application Centric Infrastructure. Then we have DNS Center, the controller that is designed for as the LAN solution or as the access solution for our campus area network. And then in both LAN and data center, both in the LAN and the data center, we are going to have some devices at the edge of our network responsible to connect our data center, responsible to connect our branches with the rest of the network, with the wide area network. So in both data center and the branches, we will have these devices called WAN edge devices. The devices that sit at the edge of the edge of your network, responsible to connect your network to the wide area network. So if you want to manage these devices from a centralized point, Cisco offers a product called SD-WAN, software-defined wide area network for next generation. So there are 3 products now. SD-WAN for the WAN network for both data center and the enterprise. For the campus LAN, we have the SDA solution. And for the data center, the internals of the data center, from the LAN side of the data center, we do have this concept of ACI. You want to have full-fledged SDN solution, you need to purchase these 3 things. If you want to have complete SDN solution in your infrastructure, then considering the point that your company has branches, your company has the data center, and they are all connected with the help of various transport. If you want to achieve full SDN capabilities, if you want to take the benefits of the complete SDN capabilities, then you will need to go for SDA, you will need to go for the ACI data center, and you are going to connect the WAN devices with the help of the SD-WAN solution. Software-defined approach to manage the campus LAN is called SD Access or SD-LAN. Software-defined approach to manage the data center is called ACI Epic. The software-defined approach to manage the WAN is called software-defined wide area network. Software-defined data center, software-defined WAN, software-defined LAN. At the moment, unfortunately, we have 3 different controllers for these 3 tasks. DNS Center, also known as Catalyst Center nowadays. For the ACI, we have Epic, Application Policy Infrastructure Controller, and for the SD-WAN, we have a dedicated controller referred to as vManage. We have multiple controllers, but we have a controller called vManage. vManage, we have a different name for it now, but vManage. We have a different name for this now, but we have a controller called vManage. There are multiple controllers, by the way. vManage, vSmart, vMount, multiple controllers are there. They also have now been renamed. So manager, controller, orchestrator, or validator, we have different names for them. But eventually in the SD-WAN, we are going to have 3 controllers. This is the overall picture of the software-defined networking SDN solution offered by Cisco. Other vendors might also provide same type of services, but since our content is Cisco specific, these are the services provided by Cisco.
Surendra, I have a quick question. I'm sorry.
Yeah.
So if you see that diagram, so ACI data center and those 2 routers are connected with the ACI data center, ACI,
Yes.
right? So those routers are managed by the ACI, or the same router are connected to the SD-WAN? So
SD-WAN. So ACI is for the LAN. ACI is for the LAN environment, and these routers are, since the WAN routers, these are managed by the SD-WAN. These are managed by the SD-WAN.
So those routers which are connected with the ACI are managed by the SD-WAN, right?
Yes, correct.
Okay,
correct.
And those
routers that sit at the boundary that are responsible to connect your network to the WAN, are managed by the SD.
So how these routers are connected with the ACI? I'm a little confused because
No,
from the SD-WAN.
we will not be discussing that. That is part of the data center certification. Just to give you the idea, just like in our traditional environment, we have like some switches. For example, these are the access layer switches. Then we have the distribution layer switches. Then they are all connected like that. And then we have connected a few routers so that we can connect our network with the rest of the network. So this is what we refer to as like LAN. This is what we call WAN. Similar to that, the ACI data center follows a different type of topology. In that topology, we are going to have some devices connected. In that topology, the routers that we will connect will be responsible to connect that data center with the rest of the network. But for that, you will have to understand the topology that is there in the data center environment, how it is built, how the connections are there. So that is specific to the data center. All we need to know at this point, all we need to know that there are a few routers in the data center environment which are responsible to connect our data center with the WAN. And these routers are managed by the SD-WAN solution provided by, offered by like Cisco. What exactly is the LAN side, how the connectivity is in the LAN side, we don't care. That is all in the data center. It is going to be very much similar. It is going to be very much similar as our campus local area network, but that completely depends like how the company has created their data center topology and how they have or where they have placed the routers responsible to connect the data center with the rest of the. So for that, you will have to have the understanding of the data center technology. Same goes for LAN. We are not going to talk about the campus local area network. No matter how the connectivity is there in the LAN side, we really do not care about it. All we care is that we have two, for example, or one maybe device sitting at the edge of our enterprise network, connecting our enterprise network with the wide area network with the service providers, ISPs and all. And these routers are managed by the SD-WAN solution offered by internal connectivity can be in whatever way they choose to connect. We really do not care about the internal connectivity. It is part of the campus area network. It is part of the data center network. When you study in the switching section, if you want to know about the software-defined access, you will study that in the SDA curriculum. And if you want to know about the data center infrastructure, how the topology is built and how the connectivity and everything is there is a dedicated content for the same. Our LAN is connected with the WAN edge router. WAN edge routers are responsible to provide the connectivity of our campus LAN with the rest of the network. That is all we need to focus on. And these routers will be managed by the SD. Basically, these routers might learn the routes from the LAN, advertise it to the other sites and all. So we don't need to focus on the LAN part. We just need to focus on the WAN. We don't need to worry about the LAN side of the network. We just need to worry about the WAN side of the network. LAN side of discussion is done dedicatedly in the other. Right. So this is like the overall picture of the SDN solution offered by Cisco. Other vendors also provide these kind of solutions, but this is the solution offered by Cisco when it comes to software-defined network. And we were already using like technologies such as DMVPN and all. We were already using these kind of technologies such as DMVPN, where like the devices will form some sort of like VPN tunnel. Devices will form some sort of like VPN tunnel, like from here to here. From for example here to here, from here for example to here. Some here to here, some here to here, here to here. So over a public network such as internet, we were already using this technology called a DMVPN, where the devices are supposed to form various VPN tunnels, and using those VPN tunnels, they are supposed to send and receive the data from one network to the other. Before this SD-WAN came in the market, Cisco also had one more technology. Like before this SD-WAN came in the market, before Cisco acquired this Viptela, and all, Cisco also had this thing called I-WAN. If you ever came across this term, I-WAN stands for Intelligent WAN. Cisco Intelligent WAN technology. It was initial SD-WAN offering from Cisco. Initially, Cisco used to offer the SD-WAN functionalities based on this thing called I-WAN, Intelligent WAN. It works around the principles of the DMVPN. So one of the key thing that this I-WAN uses is this concept called DMVPN. It works on DMVPN. It will use your existing DMVPN infrastructure, and it will use this protocol referred to as the performance routing. PFR version 3 is the latest version of the performance routing protocol. So using the performance routing over the DMVPN in the I-WAN technology will allow to have a little bit features of the software-defined wide area network that we have nowadays, such as transport independent, application optimization. We can optimize our certain application traffic to go from one path over another path, secure communication. It will reduce the overall operational cost in doing the troubleshooting, managing the network. So I-WAN was also a technology which was initially offered by Cisco when it comes to software-defined network. And in some places, we still see this I-WAN technology. In some companies, in some organizations, you might still see this I-WAN technology in use. It is a very old technology, by the way, works on the DMVPN and the concept of performance routing. But nowadays, like most of the companies have gone to the software-defined networking based on Viptela or Meraki. But this is like this I-WAN technology they can also go for, which is based on this thing called DMVPN and PFR. PFR stands for performance routing. There are official documentations from Cisco that you can refer to find out like how to deploy this I-WAN network, how to operate on this I-WAN network, how to deploy this PFR and all those things. There are plenty of documentation, and you might still see companies using these I-WAN devices, the companies still using these like I-WAN technology. Companies might still be using this I-WAN technology actually for say. It is not needed for you to know, but just in case if you want to know, you can refer to this blog. I am sending you a link just in case if you want to read about it. What was this initial offering from the Intel? What is this I-WAN and all? This is one blog from Cisco. I am sending the link in the chat. You can just click on it, and here you can just read about the I-WAN technology, read about the official documentation from the Cisco, regarding how does I-WAN works, what are the advantages we get in the I-WAN. There's no need of it, but just in case if you want to get an understanding, you can refer to these documentation, Cisco validated design. So Cisco validated design deployment guide. So you will at least, if you are aware with the DMVPN, you will be very easily able to understand how this I-WAN technology actually works. Again, not part of our content. It was just for your knowledge that you can learn about this I-WAN technology as well. Intelligent WAN or I-WAN was the initial offering by Cisco when it comes to SD-WAN solution. Then they acquired Viptela. Viptela was a company who was creating the software-defined WAN solution. So Cisco acquired Viptela, and their SD-WAN offering became Cisco SD-WAN offering. So Cisco SD-WAN Viptela came in the market. So these are the solutions that we get. These are the things that we get when it comes to a full-fledged SDN solution. These are the three offerings from Cisco. In this also, Cisco offers two SD-WAN solutions. One SD-WAN solution that we have is like Meraki-based SD-WAN. One SD-WAN solution that we have is Meraki-based SD-WAN. Meraki. And one is like the Viptela or Catalyst nowadays called Catalyst SD. We have Meraki-based SD-WAN, and one is like Catalyst SD-WAN. There are two SD-WAN offerings still, as Cisco offers like two SD-WAN offerings. One is like Meraki-based SD-WAN, and one is like the Viptela-based SD-WAN. Targeted for small users, like where the number of users are not very much. They have specific devices. They have specific security appliances. They have a specific like switches. They have a specific like access points. They have cellular devices, for example, under the Meraki dashboard, under the Meraki portfolio, under the Meraki product line. If you go through the Meraki products, if you search like what products Cisco offers when it comes to like Meraki. So Meraki is the technology that Cisco basically offers, and in this technology they have like different devices. Like we have like wireless access point, we have security appliances, we have different types of devices. They have different types of devices. They have like wireless devices, switching devices, MDM devices, different types of, say, SD-WAN devices, gateways. They have different types of devices under the Meraki portfolio. You can just purchase these devices, install these devices in your infrastructure, install the access point, install the switches, install the routers, cellular gateways, install these devices in the infrastructure, and you can just manage all these devices directly from the Meraki cloud. So they give you a cloud-based dashboard. They give you like a cloud-based dashboard. From that dashboard, you will be able to manage the particular device from a centralized point. Just like if you are aware, just like the wireless LAN controller, just like the WLC is responsible to manage all the APs, similar to that, this Meraki dashboard will be responsible to manage all the Meraki devices from one centralized. They have different products for the same, different switching products, different access points. They have different products for the same. You can purchase these products, install it in your infrastructure, and you will be able to manage all these devices from directly cloud. Easy to deploy, easy to manage, maintain, but more targeted for the small users, where we do not need to enforce like very complex policies and all. We don't need to be involved in a very complex routing and all. So, we can manage our basic like medium to small infrastructure just based on these Meraki. It's completely cloud based. You will access all these devices from the cloud. You will have to purchase the Meraki compatible devices and manage all these devices from the cloud.
So that is the major difference between these two technologies, sir, because
Yes, correct.
they are
One is
almost
completely cloud based, targeted for medium to small organizations. Different products are there. You can purchase those products, install it, and those products register themselves on the Meraki cloud. And then from the Meraki cloud, you will be able to manage the functionalities of them. So very simple setup, cloud based, like, you get like different options. It's basically like completely like cloud based solution. It's more like we are going to manage all the devices from a centralized point. So for that purpose, we are going to go for our Meraki based solution. However, SD-WAN solution that we have in the market, SD-WAN solution is more targeted for those people. Viptela, I'm talking about the Catalyst SD-WAN solution or Viptela SD-WAN solution. It is targeted for that audience who have like many branches, headquarters, data center, connected all of them over some sort of WAN transport, who want to enforce proper routing policies, templates, all those kind of things, security, quality of service, for example, all those things they want to enforce from a centralized point. So for a medium to large or very large network, as the Catalyst SD-WAN solution is going to be much more beneficial. But for that, we will need to deploy the controllers. We will need to make things reachable. We will need to do some more like additional things, which we don't need to do in the Meraki based SD-WAN solution. Meraki is completely cloud based. In the Viptela one, we will need to do certain deployments of the controllers and all, and we will then be able to manage everything from centralized. Viptela SD-WAN or Catalyst SD-WAN is more robust. It gives you more control over the network as compared to Meraki, which just provides you a basic dashboard from where you can do various things. Basically, Meraki SD-WAN does not offer like a lot of functions as compared to the Catalyst SD-WAN. Catalyst SD-WAN offers like a lot of functions such as templates, policies, quality of service, security, routing, basic to advanced routing, multicast, and plenty of functions. Viptela or Catalyst SD-WAN basically. Meraki, however, is more easy to deploy, more easy to maintain. We don't need to deploy any like controllers also. Just purchase the Meraki devices, install it in the network, and just manage those devices directly from the cloud. Basically, for the small network, simple networks, the Meraki-based SD-WAN might be much more beneficial. And for the large enterprises or the complex network, for example, where the requirement of policy, requirement of routing, requirement of security is there. For the large enterprises, typically the Viptela SD-WAN solution or Catalyst SD-WAN solution is much more. Meraki SD-WAN solution is completely cloud managed. You don't need to deploy. You do not need to deploy like any controllers. You can just purchase the devices, register those devices on the Meraki cloud, and do various things from the cloud itself. Here, in case of Viptela SD-WAN or Catalyst SD-WAN, we will need to deploy the controllers. We will need to make them reachable to the routers, and then we will be able to configure the routers from a centralized point. More complex, but gives you more control as well. So different requirements are there. A lot of companies still prefer using Meraki SD-WAN rather than Viptela based SD-WAN. Of course, costing is going to be different as well for the Meraki based SD-WAN and the Viptela based SD-WAN. So the costing will be different as well. So some medium to small businesses, they still prefer to use like Meraki based SD-WAN instead of using the Viptela based SD-WAN solution. But the large enterprises having different branches with different requirements of policy and segmentation, they still prefer to use Viptela based SD-WAN solution. If you search like Meraki dashboard, if you just search like Meraki dashboard, you will see that, let me show you. If you just search like Meraki dashboard, you can just log into this Meraki dashboard with the credentials that are provided to you. And from here, you can just manage everything from a centralized. It gives you, if I go to the images, it gives you like this kind of access. So this kind of access you will be, this kind of user interface you will be provided, from where you can manage like all the devices in a centralized way. You can also do the monitoring from a centralized way. So for the small to medium businesses, Meraki is the large enterprises, Viptela SD-WAN or the Catalyst SD-WAN is much better choice. I'm giving you a link in the chat again. It is a YouTube video that you can watch to know more about like how the Meraki dashboard actually is there. Just a random YouTube video. You can take a look at that video and see how the Meraki basically dashboard works, how the registration and everything is being done and everything. So you can, for example, purchase these devices. You can purchase these Meraki-based devices. It is 100% centralized cloud management for security networking application. Purchase the devices, register them into the cloud, and then you can manage everything from the Meraki cloud. Everything, you can manage all these things from the cloud itself. See, this is like the dashboard. This is more like the Meraki dashboard, and from here you can manage the things like security, users, and all these things. So just watch a video and know what options of configurations and everything is provided by the Meraki dashboard. It will not give you like same level of access as the same level of control as the Viptela SD-WAN, but still it is going to give you like plenty of like functionalities of the software defined wide area. Like I said, what degree of control we get is completely dependent on the solution. How much control we get on the control plane, how much control we get on the data plane, how much control we get on the management plane is completely dependent on the solution that we are. So in case of Meraki, it's more like we are doing the management from the centralized point, and we are pushing certain configurations from the centralized. All the devices still needs to do the data forwarding. All the devices still needs to perform the control plane functions by themselves. These are the overall offering from the Cisco so far. Any questions, any doubts? If you have whatever content we have covered so far, if you have like any doubts, any questions.
One quick question regarding suppose. Sorry. Yeah, so suppose I have an existing setup with a Viptela, and tomorrow we acquire a company. They are on Meraki. Can it be integrated between the Viptela and Meraki?
No. Either the device will be like managed by the Viptela based SD-WAN solution or by the this Meraki based SD-WAN solution. So your audio is very low. Like, what exactly?
I mean, we cannot integrate, but we have to migrate them.
You can migrate from like one solution. That is possible. You might face the connectivity issue. You might face the loss of connectivity a little bit, but it is possible.
Okay, all right. Thank you. And what about the integration between like a Viptela and other third-party vendors SD-WAN solution?
That is also not there. The Viptela SD-WAN solution will be responsible to manage the Viptela SD-WAN devices only. So when it comes to integration, you will not have a direct way to integrate it with the other vendors. somehow via the data center, you might need to redirect your traffic. So not direct integration is basically not applicable, not at least yet.
Okay.
What is then this software-defined networking? Software-defined networking is basically an approach of managing the network infrastructure with the help of some software. SDN, or software-defined networking, is an approach to physically abstract the control plane from the data plane and to be able to manage all the infrastructure from a centralized point. SDN is the approach to physically abstract the network control plane. SDN provides us the ability to abstract or separate the control plane from the data plane, and we will be able to manage the entire infrastructure from a centralized. So earlier, every device has their own set of control plane, data plane, control plane, data plane, also the management plane. That's why each and every device needs to be managed individually. Control plane functions, data plane functions needs to be managed individually. Distributed control plane, distributed data plane, distributed management plane is there. But when it comes to software defined, in case of SDN or software defined networking, completely depends. But the control plane functions and the management plane functions can be centralized, and the devices will be left only with the functionalities of the data plane. Things such as encapsulation, decapsulation will be performed. The data forwarding will be done by these devices, but their control plane and management plane functions are going to be centralized. But again, repeating the same exact thing, what level of centralized control we will get completely depends on the SDN solution that we are. So we have the now in the software defined networking, we have this infrastructure layer. In the infrastructure layer, we have infrastructure devices, routers, switches, different types of devices that we have placed, connected together and make them reachable. Then we are going to use some SDN control software. The software that is responsible to manage all these devices from a centralized point, configure all these devices from the centralized point. With the help of various protocols, this software is going to interact with these networking devices. And we are going to interact, we can interact with this, for example, software with the help of like applications. We can use various applications. We can navigate through the user interface, like graphical user interface or web user interface. We can also navigate through the user interface, or we can use certain application to interact with that SDN software. We will define our intent, and based on our intent, the SDN software is going to configure or control all these devices from a centralized point. What degree of control we get, what level of control we get, that completely depends on the SDN solution. The software-defined approach to abstract the control plane from the data plane and to be able to manage all the devices from a centralized point is what we refer to as the software-defined networking, or SDN. Multiple offerings are there: SD-WAN, SD-LAN, or SD-Access, and the ACIE data center. Focusing only on the SD-WAN solution, a software-defined wide area network SD-WAN solution provides all these functions. We are talking about, by the way, Cisco Catalyst SD-WAN. So Cisco Catalyst SD-WAN provides all these functions: transport independent WAN fabric, different routing, security, segmentation, quality of service, multicast, survivability, service insertion, and different like functions are provided. We can also enforce different types of policies, such as application visibility and SLA, per VPN segmentation, and whatever. So we have different application policies that we can deploy in our SD-WAN. So we can operate, we can monitor, and we can analyze the entire WAN network from one centralized point. From one place, we can manage, we can operate the entire WAN edge devices, we can monitor those WAN edge devices, we can analyze, we can see the utilization of various things from a common dashboard. Following the concept of zero trust workspace. None of the devices in the workspace are trusted. Each and every device, zero trust, zero touch. There is a possibility that the WAN edge device that we want to deploy We do not even need to touch that device. The device can be deployed automatically with the help of this process called ZTP or PMP. And until the devices get authenticated, authorized, they will not be allowed to join. So zero touch, zero trust workspace we get in our Catalyst SD-WAN infrastructure. Everything that you see here, all these things that you see here, all these functions that you see here, these are provided by the Cisco Catalyst SD-WAN solution. One by one, we will discuss about it. But these are all the these are all the options. These are all the things provided by the Catalyst SD-WAN solution. The very first function that the Catalyst SD-WAN provides is transport independent WAN. The responsibility of WAN will now be just to connect two devices. You can use whatever WAN technology. You can use any WAN technology as per the amount of money your company allows. You can use any WAN technology, such as, for example, internet, maybe 4G LTE, maybe, for example, MPLS. You can use any WAN technology that you want to in order to provide the connectivity between the WAN edge devices. The WAN edge devices will be just responsible. The WAN edge devices will just be responsible to provide the connectivity between the two devices. The WAN technology that you will be using, the WAN technology will be responsible just to provide the connectivity between the two devices. You don't need to go for costly MPLS solution. In order to connect two WAN edge devices, you can utilize, for example, one service provider, and you can utilize the second service provider, ISP1 and ISP2. Instead of going for a costly MPLS solution, we can go for two service providers, or we can go for 4G LTE, or we can go for like cellular. We can use whatever type of technology we want to use to provide the connectivity between the WAN edge. Security is not going to be a challenge. Deployment is not going to be a challenge. You can use whatever WAN technology. No need to be dependent on MPLS as your primary transport, public internet as your secondary transport, DMVPN, IPsec, all those things you don't need to do. Just make sure that the devices are reachable. Just make sure that these two devices are reachable. Transport independent WAN. You can use whatever transport you want to use, as simple as a broadband connection, MPLS, cellular, internet, whatever kind of transport you want to use. You can use any kind of transport. You can use any kind of transport. Transport independent WAN fabric. And since now the customers have the choice not to use a costly MPLS transport, but utilize like multiple ISPs like ISP1 and ISP2, the customers can completely remove the MPLS transport from their network and just go for two ISP connections, maybe go for the broadband connection, maybe go for 4G LTE. That is why some people started saying that SD-WAN is going to replace the MPLS, which is completely like it's not going to happen, not at least anytime soon. So if you know about the service provider network, if you have ever worked on the service provider network, or you have completed the routing content that we talk about, then you will know the use case of the MPLS technology, and you will know that the MPLS technology cannot be replaced sooner as they say that SD-WAN is going to replace the MPLS. It's not. From the customer point of view, they might be true, but that thing is completely subjective on the understanding. From the customer point of view, now earlier I used to connect my WAN edge devices with the MPLS and the internet. From the customer point of view, now what I can do, instead of using a MPLS solution, I can go for like different internet connection, or maybe 4G LTE, or I can use a less costly transport. So from the customer point of view, that might be true, that the MPLS technology we don't need anymore. We can use simple public internet, simple like 4G LTE or these kind of transports to provide the connectivity. But is it going to like eliminate the MPLS from the world? It's not going to happen, because go ahead and learn about the service provider. Go ahead and go through the concept of MPLS as in our routing content, and you will know the use case of the MPLS within the service provider network, it's not going to be, it will not be gone until like every device in the service provider network decided to use some other technology, some other path to forward the traffic. So that's not going to happen in time. From the customer point of view, customers now have a choice. Customers, they now have a choice to either go for a costly MPLS solution or maybe go for a less costly 4G LTE or these kind of. Second advantage that we get in our SD-WAN is that from a centralized point, I can do all the things. Everything that we want to do, we can do from a centralized point. We can use any WAN technology to connect multiple devices, and we get complete visibility from a single pane of glass, which basically means that we can manage, we can configure, we can monitor, we can troubleshoot, we can do all the things from a centralized point. We have a centralized management plane concept. From a centralized point, we can manage all the networking devices. Not only manage, we can also do the configuration on those devices. We can also do the troubleshooting on those devices. For that, they have a controller. Centralized management plane. Centralized management plane. For a centralized management plane, they created a software and they call that software vManage, also known as Catalyst SD-WAN Manager nowadays.